Good morning, good afternoon, or good evening. This is Miss Bauer here, and today we're going to talk about parent functions. Now, I like to think of a parent function as the most basic form of a function. You've seen quadratic equations before where it's something like y equals 3x squared plus 2x minus 7. But what we're going to talk about is just y equals x squared, and then later we're going to get into the transformations that change and shift these parent functions around the graph. So we're going to start off with our linear parent function. Now, instead of y, I'm just going to use f of x, even though it's the same thing. So instead of saying y equals x, I'm going to say f of x equals x. And that's our linear parent function. Now, whenever you're having trouble graphing something, don't forget that you can just plug in points and make a table and then use that table to graph. So that's what we're going to do here. So I'm not going to worry about slope or y-intercept or anything. I'm just going to plug in -3 for x. And if x is -3, then f of x or y would also be -3. If I plug in -2 for x, well then y would also be -2. If I plug in -1 for x, then y would also be -1, and now you're starting to get the picture. So just remember that f of x is the same thing as y. If I plug in 0, I'm going to get 0. If I plug in 1, I'll get 1 and 2 and 2 and 3 and 3. So if I were going to go graph this down here, remember that this is our x-axis and this is our y-axis. And so to plot points, I always go here first, then here. So 0, 0 is our origin. That's on our graph. 1, 1 would be over 1, up 1. 2, 2. Or I could do -3, 3, which was left 3, down 3. So right there. And it makes a line. So there's your linear parent function, just like that. Now, if we get into domain and range, remember that your domain is your list of all your x values, and these arrows mean that it keeps going. So that would be all real numbers, or as we're going to write it, -infinity to infinity. Our range would go from bottom to top. It would be all of your y values. And because x can be anything, well, y could be anything. Now, an x-intercept is also called a 0. It's just where our function's going to cross the x-axis, and the y-intercept is where this function will cross the y-axis. So if we look, that point was at the origin, so our x-intercept would be 0, 0, and our y-intercept will be 0, 0. Now, we're going to skip these next 3. This is stuff that we'll talk about later on in class and later on throughout this 9 weeks and semester. But for now, we're just going to focus on getting these graphs on our chart and seeing what they actually look like. Now, if I asked you to find f of 7, that just means that instead of x back up here, you're going to replace that x with the 7. And if you plug in 7, well, then f of 7 would be 7. So f of 7 equals 7 because x was 7. And that's how function notation works. Anytime you have a number in here, you're just replacing the x with whatever that number is. So if you had y equals 2x plus 3, f of 7 would just be replacing the x with a 7. That's it. Now, on to our next parent function. This is the absolute value parent function. Our absolute value parent function is f of x equals the absolute value of x. Now, our functions are going to get a little bit crazier, but for now, we're just keeping it simple and basic. That's the whole key with the parent function. So I'm going to plug in some values for x, and then we're going to see what we get for f of x. Now, remember that absolute value takes what's inside and makes it positive. So if I plugged in a -3, that would become a +3. So -3 would become a +3, -2 would become a +2, -1 would become a +1, 0 would remain unchanged, and all of our positive numbers, 1, 2, and 3, would stay the same. So if I start out with this -3, 3, that means that I'm going to go left 3, but then I'm going to go up 3 on my graph. -2, 2 means I would go left 2, up 2. -1, 1, left 1, up 1, 0, 0, and then my numbers went back up on the other side. So absolute value is going to make this kind of V pattern as you're seeing here. And that's because absolute value isn't going to give you an output that can be negative. Anytime you're plugging a number into absolute value, it's always going to be positive. So notice that it kind of bounces back up where we started having those negative numbers in the mix. Okay, for this, your domain could be anything. You can plug in negative numbers or positive numbers. So negative infinity to infinity would be our domain. But for your range, anytime you're plugging in a negative number, it's always going to bounce back up to the top and give you a positive output. So your range from bottom to top would be from 0 all the way up to infinity. And just like our linear parent function, it has intercepts at 0, 0. And if you had to find f of -7, well, now instead of the absolute value of x, you're just going to plug in the absolute value of -7, which would be +7. So f of -7 equals 7. And remember that you can always do that to give yourself extra points on your graph if you choose to do so. Now we're on to our quadratic parent function. Now, the quadratic parent function is f of x equals x squared. If you plug in a -3, remember that -3 times itself, so -3 squared, -3 times itself is going to be positive, so it's going to give you 9. So it's kind of similar to that absolute value. If I plug in -2, well, what's -2 squared? -2 times -2 would be +4. What's -1 squared? Well, -1 times itself is going to become a +1. 0 would give you 0. Remember that 1 squared is 1, 2 squared would be 4, and 3 squared would be 9. Now you could keep going to 4 squared is 16, or you can go the opposite direction and say, what's -5 squared? And that would be 25. But as you can see, these are tiny graphs, so that would put us off of our graph. Now, I still am passing through the origin 0, 0, and I have 1, 1, similar to my other graphs, but I had 2, 4. And similar to how absolute value kind of bounced back up, -1 went up to 1, and then -2 went up to 4 as well. And that's how you get this U that so many of you are familiar with, called a parabola. Now, our domain is our set of inputs, which could be anything, so -infinity to infinity. Think all real numbers. But your range, anytime you're squaring a number, it's going to become positive. So the smallest number that you could have is 0, but you could go up to infinity. Remember that domain goes from left to right and range goes from bottom to top. So anytime you're stuck, sketch out a graph and then look at the graph to guide you. Our x-intercept and y-intercept would still be 0, 0. And hopefully you're noticing some patterns between these parent functions. Like I said, we're going to skip these next 3. Now, if you were going to find f of 8, well, just remember what's x squared. We're just going to replace the x with 8. So what's 8 squared? 64. So f of 8 would just be 64. And now we're on to the square root parent function. Now, the square root parent function is also known as the inverse of the quadratic parent function. Now, we'll talk more about inverses later, but what you do need to know is that it's going to flip several of our numbers and several of our coordinates. So the square root parent function is f of x equals the square root of x. So when I come over to my table to plug in numbers, I don't want to start with -3. Because if I ask you what the square root of -3 is, that's actually an imaginary number, which isn't going to pop up on our graph. But if I asked you what the square root of 0 is, you know that. If I asked you the square root of 9, you would know that. So let's start with 0. What's the square root of 0 going to be? 0. If I asked you what's the square root of 1, that would be 1. Now I don't want to do 2 because you probably don't know the square root of 2. So think, what's your next perfect square? And hopefully you came up with it, but our perfect squares would go 0, 1, 4, 9, 16, 25, and then hopefully you're figuring out the last one would be 36. So when you're plugging all of those inputs into your square root parent function, you're going to take the square root. So the square root of 4 would be 2, the square root of 9 would be 3, the square root of 16 would be 4, the square root of 25 would be 5, and the square root of 36 would be 6. So this is going to give us almost half of a parabola because we're not having negative numbers here. Like I said a moment ago, those negative numbers are things called imaginary, and we'll talk more about that later. So on our graph, we have 0, 0, our next coordinate was 1, 1. But then I didn't have 2, 4. I had 4, 2. Because what's the square root of 4, 2? So that's how we get this curve. Now here's where I need to be careful. My domain wasn't all real numbers. I can't plug in any number that I want. I could plug in 0, but I can't go less than that into negatives. So for the square root parent function, my domain would be 0 to infinity, and my range would also be 0 to infinity. And our x-intercept and y-intercept, if we look at the graph, they're both going to cross at 0, 0. Now, down here, if I asked you what's f of 25, well, remember the square root parent function is just the square root of x. So what's the square root of 25? 5. So f of 25 would equal 5. Now we're on to our cubic parent function. Now, the cubic parent function is f of x equals x cubed. And in a moment, we're going to get to the inverse of that one, which would be the cubic root, or known as the cube root. Notice that I put that 3 really small in that little corner. It's not 3 times the square root, it's a cubic root. Now, a cube number means that it times itself 3 times. So if I plugged in -3 and I asked you what's -3 cubed, that would be -3 times -3 times -3. Now remember that 2 negatives will make a positive, but that other negative is going to flip it back to being negative again. So ask yourself, what's 3 times 3 times 3? And then that negative would make that -27. If I asked you what's -2 cubed, that would be -2 times -2, which is +4, but times a -2 again, which would make that number -8. -1 cubed would be -1. 0 times itself or anything would be 0. 1 times 1 times 1 would give you 1. 2 cubed would give you 8. And 3 cubed would give you 27. Notice that I can have negative inputs and outputs for a cubic parent function. So down here on my graph, I have 0, 0, 1, 1. But then when I went to 2, I shot all the way up to 8, which is actually going to go off my graph. And then if I had -1, that gave me an output of -1. And if I plugged in -2, that gave me an output of -8. So while I'm in this first quadrant, I'm also going to go down to this quadrant over here. So I'm going to go ahead and sketch this out. And it's almost like this parabola kind of turns and twists for a cubic parent function. Now, like we said earlier, you can have positives and negatives. So that would make our domain from -infinity to infinity, our range from -infinity to infinity, and as we can see from the graph, our x and y intercepts are 0, 0. Now, if I asked you to find f of 2, that's just me asking you, what's 2 cubed? Well, we said it earlier. That would 2 times 2 times 2 is just 8. So whenever I go over to do my cube root parent function, I don't want to plug in -3 because I don't know what the cubic root of -3 is, but I do know that the cubic root of -27 is -3. So similar to what I did a moment ago with my square root, I'm going to go ahead and plug in what I know are perfect cubes. Because what's the cubic root of -27? Well, we said a moment ago that -3 cubed is -27, and now I'm going in the opposite direction. So the cubic root of -8 would be -2, cubic root of -1 would be -1, 0, 1, 2, and 3. So when I go to graph this, I'm going to be careful because it's not going to look exactly like this one. It's actually going to be turned a little bit. I still have 0, 0, 1, 1, and -1, -1, but then my next coordinate's going to be 8, 2, or -8, 2. So -8, 2 means I'm going to go left 8 and down 2. So now I'm going over here, and 8, 2 means I'm going to go right 8 up 2. So now I'm going over here. And as you can see, this is still falling in the same quadrants. And our domain and range are going to be the same. But instead of going down to up, this is now going from left to right. So our domain is still the same, -infinity to infinity. Our range is still negative infinity to infinity. And as I can see from my graph, it passes the x-intercept and the y-intercept at 0 for both. And then if I asked you what's f of negative 8, well, what is the cubic root of negative 8? That's just negative 2. So hopefully you're getting a little bit more comfortable with this function notation. Now, you might have seen some of these functions before, but what we're going to get into are probably a little bit new for some of you. And these are key functions that we're really going to dive into in Algebra 2 this year. So our rational parent function is sometimes known as a reciprocal parent function. This is going to give you a fraction graph. So f of x equals 1 over x. So if I plug in negative 3, I end up with 1 over negative 3, which is really just negative a third. If I plug in negative 2, I'm going to get negative a half. If I plug in negative 1, well, 1 over negative 1 is really just negative 1. But this is where I have to be careful. You can't have 0 in the denominator of a fraction, so 0 is going to give you undefined. You're not going to be able to see it on your graph, which means that this right here is going to adjust our domain and our range because I can't have 0. I physically can't put 0 in there. There's no way that this function's ever going to equal 0. If I plugged in 1, I would get 1. If I plugged in 2, I would get positive 1/2. If I plugged in 3, then I would get positive a third. Now, where you have to be careful with rationals is that this might start to look kind of linear, but it's actually not. Because if you plugged a fraction in, if you have 1 divided by a half, that ends up becoming 2. So if you have a half at 2, but if you have 2 at a half, it ends up giving you these kind of curves in your quadrant. So one's going to look like this. And I'm trying to be really careful and not cross my x and y intercept because we just said that it was undefined at 0. And then on the other side, it's going to look kind of like this. Now, it's okay if your graphs are not perfect. Now we're getting into some graphs that are going to be a little bit more difficult to draw. You are welcome to go to Desmos actually and type these in and just see what they look like if you want something. I'm totally fine with that. But for now, I'm good with just a sketch. If you know that the rational parent function's not going to cross there, and you could tell me why. So whenever we get to our domain, it can't be 0. It can get close to 0. It can approach 0 from the left. But then it's going to skip it, and then it's going to keep going. So my domain would be from negative infinity, approaching 0. So I'm going to use a parenthesis and not a bracket because it can't equal 0. And then that u for union, it's going to pick up on the other side and go from 0 to infinity. Now our range is bottom to top, and it's going to do the same thing. It's going to get close to 0 from the bottom to the top, but you can see it's not actually going to cross through. So it's going to be the same as our domain. Negative infinity approaching 0, but not actually 0, and then I'm going to go over it and go up to positive infinity. Now, because of this doesn't cross your x-axis or your y-axis. So this actually has no intercepts. Which means that if I asked you to find f of 0, you can't. You can't plug in 0 to the rational parent function because you can't have 0 in the denominator. So you could just write undefined or NA. Now, our exponential parent function is just a base with an exponent. We could use 2, we could use e, which we'll talk about later. We can use 10, but for now, I'm going to go ahead and just use 2. So our exponential parent function is f of x equals 2 to the power of x. Now, you can have negative exponents. If you have 2 to the power of negative 3, what that means is 1 over 2 to the positive 3, and we said that 2 cubed was 8. So you can have an input of negative 3. It still is going to give you a positive number. It's just going to be 1/8. If you had -2, that would be 1 over 2 squared. Well, 2 squared is 4. So if you plugged in -2 for your exponent, that would be 1/4. And if you plugged in -1, think anything to the first power is just itself. But if it's a -1, that would be 1/2 because that 2 is going to be on the bottom. And then anything to the 0 power will always be 1. So don't forget that any number to the 0 power will be 1, but 2 to the first power will just be itself too. So if I had used a base of 10, 10 to the first power would be 10, but 10 to the 0 power would be 1. So just something to keep in mind. And then 2 and 3 you could probably figure out. If I asked you what's 2 squared, that would just be 4. And then what's 2 to the power of 3? 2 times 2 times 2 is 8. So if we take a look over here at this graph, it's going to cross at 0, 1. And then if I plugged in those negative numbers, it got increasingly smaller. And when I had positive numbers, it got increasingly bigger. So this is going to curve like this. Now, notice when I plugged in negative values, it didn't actually make these numbers negative, it just shrunk them. And that's because for this function, your domain can be anything you want it to be. But even if you plug in negative numbers, it's not actually going to give you 0. So in this case, our range is going to be from 0 to infinity, which means I don't have an x-intercept. There's not a situation where it's going to cross the x-axis because like we said for the range, it's going to kind of start above 0 and like increase up. But our y-intercept, I can see that it crosses the y-axis at 1. So our y-intercept would be 0, 1. And then if I asked you to find f of 3, just remember that that's just plugging in 3 for x. So 2 cubed is 8. So f of 3 would equal 8. And that brings us to our 9th and our final parent function, which is a log function or logarithmic parent function, but log function for short. Now, a log function is just the inverse of our exponential function. So it's okay if you don't know all of these logs, and this is something where if you want to go to the calculator and kind of type it in, I'm okay with that, but I'm also going to walk you through it. So your log function would be f of x equals log base 2, because that was my base that I had earlier, of x. Which means that now I'm going the opposite way. So if I have 1/2 as my input, that means that my exponent had been -1. When I had 1 over here as my output, that meant that my input had to be 0. When I had 2, my exponent was 1. When I had 4, my exponent was 2. And when I had 8, my exponent was 3. And hopefully you're kind of getting the picture here. So as I go over here, at 1/2, I had -1. 1, 0 would be right 1. 2, 1 would be right 2 up 1. And then you're starting to see how this one is going to curve this way. And like I said earlier, and I just want to state again, it's okay if these graphs aren't perfect. I just want you to kind of know, are they crossing the x or y axis? Are they increasing, decreasing? Are they going up? Are they going down? What quadrants are they in? So for this one, now notice from left to right that I have no negative numbers and that I can't have 0. So it's close to 0 like this up to infinity. But my range is going to be -infinity to infinity. And like I said, hopefully you're finding some patterns. Kind of notice that over here, back before, my domain and range are now flipping because I've changed this up. This is my inverse function. So this one has an x-intercept of 1, 0, but this has no y-intercept. And we're gonna skip these last ones. If you wanna use a calculator for this one, you can. I don't expect you to be able to mental math this. If you do it in the calculator, you're gonna get around 6.6. But we'll get more into that later. So right here, I just put the breakdown of Algebra 2 for you. So if you're freaking out about some of these exponential and logarithmic and rational functions, don't be, because we're not even going to get into those until Unit 7 or Unit 8. So hopefully you have a much better understanding of these parent functions, and you would be able to kind of sketch graphs and answer questions about the domain and range. We'll see you next time.